Good morning viewers. In last lecture we discussed about the examples of finite automata with some explanation session. So today class we will discuss about the what is transition table and transition diagram followed by the finite automata. So before going to the actual content of today presentation, we will discuss the outline of the today's presentation, that is a transition diagram and transition table. Next, types of automata. There will be categorized into the three types, that is NFA, DFA, NFA with epsilon. NFA means non-deterministic finite automata, DFA means deterministic finite automata. NFA with epsilon, transition will be different from NFA to NFA with epsilon. You can say here it is a types of automata means finite automata. Don't think about something else like linear bounded automata, that is also finite automata will come. But you think about it is a types of automata means finite automata, right? So now transition table. What is a transition table? First of all, transition table is a graphical representation of transition function. Graphical representation of transition function. What is a transition function? Delta. Delta is a transition function. State with input symbol, where input symbol epsilon, it goes to the some other state which is q. So that is which is q. It is a transition function. So states, it will show the circle transition directed as a arrows. That means that we already know states is a like is a one state, is a one more state, is for example this is a final state, this is a starting state. So it is moving from one state to the another state with the input symbol a. Let it be assume it is an input symbol a. Just I am giving example to understand, better understand. So this is the one kind of transition diagram. Simple we can say transition diagram is finite automata. So that is a simple automata. So used to visualize the NFA, DFA, NFA with epsilon. So we will discuss one or two examples, followed by the we will go to the some other concepts. So we will see the transition diagram example. Now you see there is a one state with simple I am discussing. I am not discussing much more complicated one. So first one is a Q0 is a one state which is starting state. Assume Q0 is a starting state, and one more state which is Q1, right? So one more state Q2. So let us say assume Q2 is a final state, right? Q2 is a final state. Then starting to the Q0 to the Q1, I am taking transition is A. So Q1 to the Q2, I am taking transition is B, right? So on Q1 I am taking self loop A comma B, right? So here I am taking simple transition function. I am not taking much more big complicated one. It is a transition diagram. So what is the input symbol? Input symbol is a sigma equal to A comma B, right? So this is a simple, it is a one kind of example for discussing the transition diagram. Transition diagram means simple, it is a finite state mission. Don't confuse here finite state. What is a finite state? Finite automata. Finite automata is a finite state mission. Both are, we call it the same only, but different names we call it. So we will discuss one more example with the transition table. We conclude this topic. So we will see one more transition diagram. Like this is one state which is A, one more state which is B. Let us say B is a finite state. From we take the epsilon as a input symbol A comma B. So A you take the starting state. So from A to B, we take the B is the input symbol, and B to A is a you take, this you take B, this you take self loop as a. Just I am giving one finite automata for better understanding. So as of my knowledge, what is a transition diagram? You understand. Transition diagram means simple. We can say it is a diagram which will represent the transition of the finite automata as we discussed in the previous slide. So now we will go to the transition table. So what is a transition table? Transition table is a tabular representation of transition function. What is a transition function? That is delta. Delta is q into sigma of q. So this is a transition function. So how this transition function will be represented in a form of tabular. So that is a transition table. Don't worry, we will discuss 2-3 examples so that you will understand better. So it will be rows represent the states. That means that we will what we discuss. It is a transition table is a one kind of table, right? Rows represent the states, like means that this is the represent the states, right? States, and columns represent the input symbol. Here it is a input symbol like A, B, 0, comma 1, something like that. So states mean Q0, Q1, Q2, something like that. So it will be represent in a form of rows and columns. Like we will see one example so that you will get a clear idea what to do, what not to do. So it will provide the systematic and precise way of, it will represent the systematic and precise way of transition, right? So it's not necessary that it should follow the row should be states and columns should be inputs. You can use as per your representation, but it should follow, convey the same meaning of delta function. You should not violate the delta function. If it is violate the delta function, it is a rank of the transition table. So that if delta function is correct, so transition table is a correct. So we will see the one example with the transition function. So now you take the one state, one finite automata with q0 state. Q0 is a starting state, right? One more you take the q1 is a second state, q2 is a final state. So let it be assumed q2 is a final state, right? So what is the input symbol? Input symbol we take the a comma b. I am giving same example which I am discussing just now as a representation of transition diagram. Same thing I am discussing. So q0 is a starting state. So q1 is a q0 to q1 is a start input symbol which is a, right? q1 to q2 b, input symbol is b. Now q1 having transition of a comma b. Now what we want is, I want to construct the transition table for this finite automata. So just now we discussed what is a transition table. Transition table is a tabular form which will represent the transition function, right? So that means that what is a transition function? Transition function is a delta which will represent the transition of input from one state to the another state. So we will discuss the transition table now so that you will understand. Delta is a transition function, we all know, right? So we will write a table in a form of like this, delta A B. So just now I told it not necessary that you should take the left side should be right, row wise should be states, column wise should be columns, column wise should be state input symbol, and vice versa. That means that this side row wise you can take the states or input symbol, column wise you can take states or input symbol, but it should represent the transition function. Now you take this side, I am taking vice versa, like that I am taking reverse. So this side I am taking the states. So this side I am taking input symbol. So now you see, so what are the states? States are Q0 is a one state, Q1 is a one state, and Q2 is a one state. So now check it whether on Q0 state, what is the input symbol? On Q0 state, input symbol A, where it is going? Q1. So you write Q1 here. On Q0 state, input symbol B, where it is going? Anything is going from Q0 to B, Q0 to any other state? No. If it is not going, you write pi or empty string. So this is the way to represent the transition on Q0 state. Similarly, you go for the Q1. So on Q0 state, what is going? Where it is going? On Q1 state. You write the Q1 here. So next, similarly, Q1 state, B is input symbol. Where it is going? It is going to the Q1 state and Q2 state. You write the same thing. Here, what you will write? Q1 comma Q2. So you write two states because of it is representing the two states. Now on Q2, A is any input symbol? No, pi. A is any input symbol? B is any input symbol? Pi. So nothing is there. So just you write the pi. So we will discuss one more example of some other diagram so that you will understand more clearly. So we will discuss one more example of finite automata. Q0 you take one more state, Q1 you take one more state, Q2 also you can take one more state. So Q0 is a starting state. Just I am discussing example. Input symbol you take the 0, 1. So now you take input as 0 and this you take the 1, this you take the 0, this you take 0, 1. So I am making Q2 as a finite state. So this you make the 0, this you make 1. Just I am discussing example. Here there is no discussing about more rules and regulation. Just I am discussing to better understanding of transition table. So what is the input symbol? 0, 1. So what is the state? Q0 is a state, Q1 is a state, Q2 is a state. So when you are writing any transition table, you must represent the what is the starting state. Q0 is a starting state and Q2 is a final state, right? So now see on Q0 state, what is the transition of input symbol 0? So on Q0 state, if transition is 0, where it is going? It is going to the Q1. You write Q1 here, right? So now next on Q0 state, 1 is the input symbol. Where it is going? On Q0 state. You write Q0 state here. Similarly for Q1, if you go for Q1, if it is giving 0, where it is going? Q1 state. So you write Q1 state. So if it is 1, where it is going? It is going to the Q2 state. Similarly Q2 state, Q2 if I am giving 0, where it is going? It is going to the Q2 state and Q0 state. You write Q0 comma Q2 in a curly braces, right? So next one on Q2 state, if I am giving 1 is the input, where it is going? Q2 is a state. So now I hope you understand what is the transition table, how to construct if finite automata is given to construct the transition table. So next we will go for the same. So we will discuss the reverse of this one. So that means that if transition table is given, how to construct the finite automata. So that one we will discuss now. So now you see here, I am giving one transition table like this. You take the A, B is the input, Q0, Q1 is a, let us say Q0, Q1, Q2 is a state, Q0 is a starting state, Q2 is a final state. Let us assume this is Q0, Q1, Q0, Q2, Q2, Q1. So now, like this, one transition table is given. So if transition table is given, how to construct the transition diagram, right? So transition diagram, how many states are there? 3 states. Like, so you construct 3 states like Q0, Q1, next Q2, right? So what is the starting state? Q0 is a starting state. Make it as a Q0 is a starting state. What is the final state? Q2 is a final state. Make it a Q2 is a final state. Now what is the input symbol? Input symbol is a comma B. So now start thinking about what is the transition. On Q0 state, input symbol A, where it is going? Go to the Q0, you make the self loop with A. If it is B, where it is going? If it is B, going to the Q1 state, you write like if B, then make the B as a Q1 state. Next, go to the Q1 state. If you go to the Q1 state, input symbol is A, where it is going? Q0. You make a transition like this of input symbol A. On Q1 state, on Q1 state, on Q1 state, if I am giving B is the input symbol, where it is going? Q2. You write Q2 as a input symbol, right? Next, go to the Q2 state. If it is Q2 state, I am giving A is the input symbol, where it is going? Q2. You write A is the input symbol. If it is on Q2 state, if I am giving B, where it is going? It is going to the Q1 state. You write Q1. Right. So now construction of transition table is completed. So we will see similarly, we already discussed. So now if transition table is given, we construct the finite automata or transition diagram. Right? If transition diagram is given, we construct the transition table. We will see the same example so that you will understand the better. I hope you understand everything how to construct for transition table to the transition table to the finite automata transition diagram. If transition diagram is given, how to construct the transition table. I hope you don't need to discuss about this much more. So very simple. So just you have to construct the table from if transition diagram is transition table you have to construct. Transition table is given, you have to construct the transition diagram. So what is the need of discussing this transition table to transition diagram to transition table or transition table to the transition diagram? Because of some time in an examination they will give transition diagram or transition table. It's not compulsory that they should give transition diagram or transition table. So it depends on the paper checking person, paper setter, they will give either these or this. If it is they mention a transition diagram or any transition table, they has to explicitly they has to mention the starting state and final state. These two they should mention either in the form of statement, either in the form of symbol. What is the starting state symbol will represent arrow mark, whereas the final state will represent the double-ended circle. So next we will discuss the types of automata. So in a types of automata, just now we see there are two kinds of automata, types of finite automata. Here you don't think about it is a automata, it is a finite automata, right? So there is a two kinds of finite automata, like one is like DFA, that is deterministic finite automata, it is NFA, non-deterministic finite automata. NFA we have one more, NFA with epsilon. So epsilon is a transition input symbol, as like we discussed the input symbol as 0, 1. So this is one kind of input symbol. Epsilon is a input symbol. So these are the three kinds of finite automata. So if it is NFA, like we already seen initially NFA, DFA, DFA and NFA with epsilon. Now we will see the NFA, then followed by the some DFA. Then later sessions we will discuss about the NFA examples in each session, each topic. So now on NFA, we will see now NFA. On NFA is a finite automata where multiple transition may exist at the same input symbol. That means that if you are taking any transition table, as like we just now we discussed now, like now you see here. So you can see here in a previous examples also you can see. So here you can see there are multiple transition. If it is multiple transition existed, then we can say it is a NFA, right? So that means that input symbol, if it is unique, then it is a DFA. Otherwise, it is a NFA, non-deterministic finite automata. Whereas DFA, deterministic finite automata. You can see here, it can have more or more than one next state from the given state. That means that if you take the Q0 is a one state, Q1 is a one more state. If I am taking input symbol A comma B, right? If I am taking input symbol A comma B, if you come to the Q0 state, A is the input symbol. That means that it may go to the Q0 state and Q0 state and Q1 state. So that means that from each state it will go to the same input symbol, go to the multiple states. Then we can say it is a NFA. So one more thing also here, epsilon transition move without input. That means that we are moving from one state to the another state without consuming any input symbol. That is also allowed. That we will discuss later also. We call it as a NFA with epsilon. A string accepted if at least one computation path end with accept the states. That means that in NFA definitely it should have one input symbol. It will go to the one state to the another state. Now we will discuss the formal definition of NFA. Later classes we will discuss the examples of NFA and examples of DFA. Later classes we will discuss the epsilon with DFA. Epsilon transition with NFA. So now NFA is defined as a 5 tuple entity. So as like discussed in the automata, finite automata. So that is a Q naught epsilon delta Q epsilon delta Q naught phi. So these all are common present in the automata also. Only change is this transition function. Remaining things are all are same. So what is the delta? Delta is the input symbol. What is the delta is the transition function, whereas the epsilon is a input symbol. Epsilon is the input symbol, delta is a transition function. Delta is defined by Q. Q is a state into input symbol including epsilon, right? If including epsilon goes to the 2 power q, that means that state it will reach to the 2 power q. If you substitute the 2 power 0, it is a 1 state, right? If you substitute 2 power 1, it is 2 states. So that means that if it is here it is a 2 power q is a 0, it will become into the DFA, deterministic finite automata. If it is not more than 0, it will become the, here it is a 2 or more than 2. So then it will become a NFA, non-deterministic finite automata, right? So Here there is a one function, that is a epsilon. Epsilon also it will be presented. If epsilon is not presented, so then we can say it is a NFA. If epsilon is presented, then NFA with epsilon. So there is a two kinds of automata, these also presented. May be presented, may not be presented, not necessary every NFA having epsilon transition. If it is epsilon transition is present, we call it as a NFA with epsilon. Epsilon transition is not present, we call it as a NFA. That will be, and if it is defined an output, output is, if it is 2 power, if it is unique state, that means that one state, it is, we call it as a DFA, as now we discussed. Otherwise we call it as a NFA. In a NFA also we categorize, if epsilon is there, epsilon with NFA, epsilon is not there, we call it as a epsilon. So now next is, what is Q naught? Q naught is a belongs to the Q. Q is a state. Q is a state like Q naught, Q1, A, B, something like that. So it is a state, state and initial state. It is state and initial state. F is a final state which belongs to the Q. So set of strings which will accept the strings. So this is about NFA formal definition, right? So now we will see one more example, and we will wind up the today class. Okay, so we will see one example with NFA. Just a minute. NFA with small example we will see. For example, you take the Q naught. Q naught is a one state, Q1 is a one state, right? So Q naught take the starting state, Q1 is a final state, let us assume. So I am taking input symbol A comma B, right? So now you take the transition from Q naught to Q1 is A, and it will be self loop, assume. So Q naught on Q1 state A or B, then you take, this is a B. Now construct the transition table, that is delta A, B. So here you take Q naught, Q1. Just try to understand, due to written everything. So on Q naught state I am giving A is where it is going, Q naught state, same time it is going to the Q1 state. If it is B, where it is going, B is pi transition, nothing is exist. On Q naught, Q1 state, if I am giving A where it is going, Q1, B where it is going, Q naught, Q1. If it is like two multiple entries are existed for single state with a single input, then we call it as a NFA. Otherwise we call it as a DFA. No such entries are existed in a DFA. It definitely, it must have unique transition for each input. If it is exist multiple entries, then we can say it is a NFA. Okay, so I hope you understand the what is a NFA. So much more discussion about and examples we will discuss into the next class. So I hope you understand the today class, that is the what is a transition table, what is a transition diagram. If transition diagram is given, how to construct the transition table. If transition table is given, how to construct the transition diagram, and formal definition of NFA. And I hope you understand what is the difference between the NFA and DFA with epsilon. So much more examples we will discuss into the further classes. Thank you for watching. If you like my content, please subscribe to my channel. Thanks for watching.